What exactly is between a beam of light and the edge of the universe? Most people will tell you it's nothing. They think space is just an empty, dark box, a passive, boring vacuum that light simply zips through undisturbed on its way to your eyes. Wrong. That's not just a little wrong, it's fundamentally wildly backwards. Space is not a box. It is a physical, living, expanding fabric. And here is the mind-bending truth. As light travels from the edge of the universe to us, the nothingness of space is actively stretching it. It's grabbing the waves of light and physically ripping them wider, turning invisible ancient colors into lingering radiation. You have actually felt this invisible stretching. If you've ever heard static between old TV stations, a fraction of that noise was the stretched, exhausted light from the very birth of the universe crashing into your antenna. I'm going to show you the secret mechanics of the cosmos. We are going to expose how the expanding fabric of space-time secretly wrestles with traveling radiation in the dark. Let me show you. Close your eyes and imagine shining a flashlight. You push the button, the beam shoots out, and it hits a wall. Simple, direct, unchanged. But what if that wall is a billion light years away? Here's the part nobody tells you. The space between your flashlight and that distant wall isn't just sitting there. It's alive, it's swelling, and it is actively fighting the light. Let's talk about the universal speed limit. Everyone knows the rule. Nothing moves faster than light. 299,792,458. It's the ultimate cosmic law, the hard cap. People say light is the fastest runner in the universe, but that's just a label, because this is where your intuition fails. Imagine you are sprinting through an airport. You are the fastest runner alive. Nobody can beat your top speed. You step onto one of those flat moving walkways. You're sprinting at your absolute max. You feel invincible. But look, what if the moving walkway itself starts stretching? Not just moving forward, stretching. The rubber belt beneath your feet expands faster than you can run. You are still sprinting at your absolute maximum speed. Locally, right where your feet hit the rubber, you are breaking records. But the end of the walkway is getting further away from you. You are running at top speed, yet losing ground. Crazy, right? Exactly. Now, zoom out from the airport. Make that rubber walkway the entire universe. Make the runner a single photon of light. That photon is blasted out of a distant star, hurtling toward Earth. It's doing its job, slicing through the dark. But the space between that star and Earth is the rubber walkway, and it is expanding, swelling. Here is the terrifying part. Space doesn't have a speed limit. Wait, read that again. Einstein's speed limit only applies to things traveling within space, but the fabric of the universe itself, it doesn't care about the rules. It can stretch faster than light. If a galaxy is far enough away, the space between us is expanding violently fast, so fast that the light it emits will never, ever reach us. The fastest runner in the universe has been beaten by the track itself. Now watch what this implies. If the track is stretching while the runner is running, what happens to the runner? What happens to the actual physical shape of the light wave? What happens when the floor beneath it is pulled apart? Hold that image in your mind, because the answer is going to break everything you thought you knew about colors. What happens when the floor beneath a wave is pulled apart? Let's zoom in. Light isn't just a solid beam. It's a jittery, vibrating wave. It has peaks and valleys. The distance between those peaks is called the wavelength. And your brain translates that physical distance into one very specific thing: color. Short, tightly packed waves, your brain sees blue. Longer, stretched out waves, your brain sees red. Now try this. Hold your hands out and imagine you have a thick rubber band. Take a marker. Draw a squiggly, tight wave on the rubber. That drawn wave is a beam of blue light. Now grab the ends of the rubber band and pull. Stretch it hard. Look at the ink. What happened to your wave? The peaks are no longer tightly packed. You didn't touch the ink. You didn't redraw the line. but by stretching the rubber band, the wave itself physically stretched out. The peaks got pulled further apart. This isn't a metaphor, it's literal. When light travels through the universe, the fabric of space-time is that rubber band. A distant galaxy fires off a burst of tight, energetic blue light. It begins its billion-year journey to your telescope. But remember Chapter 2? The track is expanding. As the light wave surfs across the cosmos, the very space it occupies is swelling. The space stretches, so the wave riding inside that space stretches too. The tight blue wave gets pulled apart. The distance between its peaks grows. And by the time it finally hits your eye a billion years later, the wave is long, loose, lazy. That tight blue light, it isn't blue anymore. It has been physically stretched into red light. Hold on. Think about what that actually means. The color of the universe isn't fixed. It is being actively manipulated, wrestled, and deformed by the invisible void between the stars. Space is literally changing the fundamental properties of radiation just by expanding. That sounds impossible until you see the trick. Scientists have a name for this cosmic stretching. They call it cosmological redshift. But how do we know this isn't just a wild theory? How do we prove space is stretching these waves right now? Because the universe left fingerprints, and they are everywhere. Let's talk about those fingerprints. If you take sunlight and smash it through a prism, it fans out into a rainbow. Beautiful, simple, but look closer. Slice that rainbow incredibly thin. You won't see a perfect, smooth smear of colors. You will see crisp, black lines, gaps, missing teeth in the rainbow. People say starlight is just a bright glow, but that's just a label. It's actually a cosmic barcode. Every element in the universe, hydrogen, helium, carbon, absorbs exact slices of light. When a star burns hydrogen, that gas steals a precise shade of color before it escapes. It leaves a black line, a permanent chemical fingerprint. It snaps into existence and never changes. If you burn hydrogen in a lab on Earth, those black lines sit in an exact, rigid spot, always. So, what happens when we point our telescopes at a galaxy a billion light years away? We find the hydrogen barcode. But wait, the barcode is completely in the wrong place. The lines are identical. The spacing is a perfect match, but the entire barcode has been violently slid over to the red side of the spectrum. It has been shifted. Why? Because the light itself got physically stretched out while flying through the dark. The space between us and that galaxy expanded. It grabbed those delicate little waves, pulled them like taffy, and elongated the entire barcode. This is redshift. And here is the part nobody tells you. The further away a galaxy is, the more the barcode is shifted. Why? Because the light had to travel for a much longer time. It spent billions of years surfing on the expanding rubber band of space-time. More time traveling means more space expanding. More space expanding means the wave gets stretched even harder. We aren't just guessing that the universe is expanding. We can literally measure the stretch marks in the light. Every distant galaxy is screaming its exact distance at us through these shifted, stretched-out barcodes. So far, we've learned space isn't empty. It stretches, and it wrestles with the waves inside it. But let's push this to the absolute extreme. What happens if you stretch that rubber band even further? What if the light travels so incredibly far, for so unbelievably long, that the wave stretches entirely past red, past what our human eyes can even process? If you understand this next part, your brain will physically hurt. Because the wave doesn't just stop stretching. It drops off the visible spectrum entirely. It plunges into the unseen. Where does the light go when it stretches past red? It doesn't die. It just hides. People say the space between galaxies is a dead vacuum, but that's just a label. Vacuum implies a completely empty, silent void where nothing happens. Wrong. The nothing between the stars is the most active, violent substance in reality. Let me tell you about the first time I looked at infrared telescope data. You point the lens at a patch of sky that looks completely, utterly black. Your human eyes see absolutely zero light, a total dead zone. But flip the sensor to read infrared, the entire screen catches fire. That hidden light didn't magically appear. It was always there, traveling toward us. It just got stretched so wide by the expanding universe that its wavelength snapped past the color red. It wiggled right out of the visible spectrum. Now it's infrared, pure heat radiation. Close your eyes and imagine standing near a roaring bonfire. You can feel the warmth pushing against your cheeks, even with your eyes shut tight. That invisible heat? That is infrared light smacking into your skin. The same physical process is happening in the deep cosmos. The stretching fabric of space took a blindingly bright, high-energy star and exhausted its light. It degraded a piercing beam into a weak, invisible wave of heat. But wait, what exactly is doing the stretching? What is this invisible fabric pulling the strings? Here's the part nobody tells you. Space isn't a passive, empty box. It is a boiling, seething grid of quantum fields. If you were the size of a single electron and you zoomed into an empty patch of the void, you wouldn't see stillness. You would see the void actively jiggling, a relentless, bubbling froth of energy, particles snapping into existence, wobbling for a microsecond, and popping back out. This quantum froth actually has energy. It has a physical presence, and it is literally pushing the borders of the universe apart. As this invisible soup expands, it grabs every single passing wave of light. It pulls them, it stretches them. The light is physically wrestling with the underlying structure of nothingness itself, and the nothingness always wins. Every single second a photon travels through the dark, it loses a tiny fraction of its energy to this expanding grid. Hold on, think about what that actually means. Energy cannot be created or destroyed. That is the ultimate unbreakable law of physics. So if the light wave is getting stretched and it's losing its energy, where does the stolen energy actually go? Who is robbing the light? Are you seeing the picture yet? Let's talk about a broken law. You just learned that energy cannot be created or destroyed. You learned it in grade school. Every textbook screams it. But here's the terrifying part. That rule is completely wrong. Wait, think about this for a second. A distant galaxy fires a beam of blue light across the expanding void. The light travels for 10 billion years. The space between us and the galaxy stretches violently. The blue wave is pulled into a lazy red wave. Blue light has extremely high energy. Red light has very low energy. So, over the course of 10 billion years, a massive amount of energy was lost. Where did it go? Did it heat up the surrounding space? No. Did it bounce off a rock? No. Did it turn into another particle? No. The energy just vanished. It evaporated. Gone. Poof. And nobody is talking about it. Let me say that again. The most sacred rule in physics, conservation of energy, does not apply to the expanding universe. People say the universe keeps everything perfectly balanced, but that's just a label. It's a comfortable lie we tell ourselves to make the cosmos feel neat and tidy. The truth is far more chaotic. Einstein's general relativity completely shatters the conservation of energy on a cosmic scale. Energy is only conserved locally. If you drop a bowling ball from your roof, the energy adds up perfectly. But over immense distances, over billions of light years of stretching, expanding space-time, the rules change. Space itself is doing work. It is physically expanding the light. And the universe doesn't hand out receipts for the stolen energy. The expansion just eats it. Don't blink, because this is the secret to everything. The light doesn't just stop at red or infrared. If it travels long enough, the expansion of space stretches the wave so far, so wide, that it becomes something else entirely. It drops off the infrared spectrum. It stretches into microwaves. It stretches into radio waves. A high-energy, blinding white flash of light from the birth of the universe can be stretched so thin over 13.8 billion years that it turns into a faint, lazy radio signal. And this isn't just theory. You have literally physically interacted with this exhausted, stretched-out ghost light. I remember when I first realized this. I was staring at a broken piece of technology, and I realized I was holding the literal edge of the universe in my hands. Are you ready to see the ghost? Are you ready to see the ghost? Let me tell you about the time I flipped on an old, heavy CRT television. No cable attached, no antenna, just a fuzzy screen filled with white and black snow, static, and a loud, endless hiss. Most people think static is just random electrical interference. Wrong. A tiny fraction of that dancing snow, about 1%, isn't coming from Earth. It isn't a glitch. It isn't the broken wire. It is an echo, a literal, physical ghost wave, and you are staring right at it. Here's the part nobody tells you. The static on an analog TV is the exhausted light from the very birth of the universe. It is called the cosmic microwave background radiation, the CMB. Let me say that again. When the Big Bang happened 13.8 billion years ago, the universe was blindingly hot. A searing, screaming white flash of pure plasma filled every inch of reality. That light has been traveling ever since. But remember the rule? The fabric of space has been expanding for 13.8 billion years. That blinding white light has been stretched. It rode the moving walkway for billions of years, and the space beneath it stretched so incredibly violently that the tight, blazing hot white waves were pulled apart. They stretched past blue, past red, past infrared. They stretched so completely out of shape that they turned into microwaves. Faint, freezing cold, lazy microwaves. This is where your intuition fails. The light didn't disappear. It is everywhere, right now. It is passing through your body. It is bouncing around your living room. It is hitting the antenna of that old analog TV and making the static dance. You are bathed in the stretched-out ghost of the Big Bang every second of your life. The universe isn't dark. It is glowing constantly. We just can't see the color it glows in anymore. So far, we've learned how space wrestles light into submission. But there is a terrifying problem hiding in the math. A problem so massive, it breaks the entire structure of the universe. Because if the space between us and the light is expanding, what happens if it expands too fast? Think about this right now. What happens if the moving walkway accelerates? What happens if the moving walkway accelerates? Let's find out. If the fabric of space-time is stretching waves into red, infrared, and microwaves, then it stands to reason that space is expanding everywhere. Always. Constantly. But scientists thought the expansion would eventually slow down. They thought gravity would pull the universe back together like a bungee cord snapping shut. The stretching would stop. The light would compress back, right? Wrong. In 1998, they looked at the stretch marks of exploding stars, supernovae. They measured the redshift of the light, and what they found completely destroyed their entire understanding of physics. The expansion isn't slowing down. It is speeding up, violently. Exponentially. Here's the part nobody tells you. The nothingness between galaxies isn't just pushing things apart at a steady pace. The nothingness is actively generating more nothingness, and it is pushing everything away faster and faster every single second. This is where your intuition fails. Imagine two galaxies tied together by a string. The space between them begins to stretch. The string gets tighter. Tighter. Eventually, the space expands so fast that the string snaps. Now watch what this implies. If the space between us and a distant galaxy expands faster than the speed of light, the light from that galaxy will never, ever reach us. The moving walkway is moving faster than the fastest runner. Hold on. Think about what that actually means. The light is still traveling toward us at absolute maximum speed. C equals 299,792,458. It never slows down. But the physical distance it has to cover is growing faster than it can cross it. The light is trapped in a cosmic treadmill that it can never beat. The space is expanding, stretching the wave, and pushing the source out of reach. If you understand this next part, your brain will physically hurt. Because there is a hard boundary out there in the dark, an absolute terrifying edge to what we can ever know. And the universe is pushing galaxies across that line right now. Let me say that again. Galaxies are disappearing into the dark because the rules of space are fundamentally broken. Galaxies are disappearing into the dark. People say the universe is infinite, but that's just a label. For us, the universe has a very hard, very terrifying edge. We call it the cosmological horizon, and it is a permanent graveyard of light. Imagine a bubble around Earth, a sphere spanning 46 billion light years in every direction. Everything inside that bubble is the observable universe. We can see the light from these galaxies because it had enough time to reach us. But outside that bubble, this is where your intuition fails. There are billions of galaxies right outside our bubble. They are shining brightly, emitting intense, beautiful light. But the space between us and them is expanding so incredibly fast, literally expanding faster than light itself. Remember the treadmill? The light from those distant galaxies is sprinting toward us at absolute maximum speed. But the treadmill of space-time beneath it is running backwards faster than the light runs forward. That sounds impossible until you see the trick. The light is technically moving toward us locally, but physically, the vast distance is dragging it further away. It will never arrive, not in a billion years, not in a trillion years. That light is forever trapped in the expanding void, wrestling with the relentless fabric of space and absolutely losing. Here's the part nobody tells you. Because the expansion is actively accelerating, our observable bubble is effectively shrinking over time. Every single day, more distant galaxies are pushed past that horizon limit. They cross the invisible edge, and their ancient light is stretched so incredibly far, it fades into absolute nothingness. They are gone, forever, permanently erased from our human night sky. Right now, you are living in a highly privileged time in our cosmic history. We can still look up and see the glowing, distant universe. But what happens to the human generations that come far after us? What happens when the accelerating nothingness pushes every single distant star away? Hold that thought. Because the final puzzle piece changes the entire fundamental meaning of the dark night sky. Are you truly ready now? Are you truly ready now? Let's travel 2 trillion years into the future. The relentless expansion of space-time has finally won. The moving walkway accelerated so much that it ripped the visible cosmos apart. Every single galaxy outside our local group has been pushed permanently past the edge of the horizon. Their light has been stretched so violently, so incredibly wide, that its energy has dropped to absolute zero. The night sky is entirely empty, pitch black. Close your eyes and imagine being an astronomer in that distant future. You build the largest telescope possible and point it into the void. You see absolutely nothing. You turn on a receiver to listen for the CMB static from the Big Bang. Pure silence. The universe has completely, ruthlessly erased its own fingerprints. Here's the part nobody tells you. Those future humans will look up and logically conclude they are completely alone. They will think they live in a tiny, static, boring universe. They will have zero evidence of the Big Bang, zero evidence of other galaxies, because the expanding nothingness didn't just stretch the light, it stretched the entire history of the universe until it completely broke. This is where your intuition fails. We naturally think of space as a passive stage where things happen. Wrong. Space is the main character. It dictates what we can see, what we can ever know, and what will ultimately be forgotten. It's not just an expanding void, it is the great cosmic eraser of reality. So tonight, go outside, look up at the stars. You are looking at exhausted, battered, ancient light. Light that barely survived a billion-year wrestling match with the fabric of space-time just to hit your eye. You are incredibly lucky to see it before it fades, because one day the nothingness will finally win. If this completely broke your understanding of reality, hit the subscribe button. We have a lot more universe to unravel. Keep questioning the dark. I'll see you in the next one.